Okay, so question 5 says use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation of the parabola's axis of symmetry. Use the parabola to identify the function's domain and range. Okay, and so we're going to kind of need to rewrite this one a little bit. This is the same as if we wrote this as f of x equals negative x minus 4 squared plus 9. And remember, this is in the form, our vertex form. So that is a x minus h squared plus k. And if you'll notice here, our a is a negative 1. And if you'll remember, when a is negative, our parabola will open downward. Okay, so we're going to have some kind of picture that looks similar to this. It's going to open downward because the A is negative. Okay, so if we think about our vertex is at HK, so I have my vertex is going to be at 4, positive 9 this time. And my axis of symmetry is going to be at x equals 4 again. Okay, so I'm going to come over here. We need to find some x-intercepts, don't we, and y-intercepts. So let's do our y-intercept. We're going to make x equals 0. So I've got y equals negative 0 minus 4 squared plus 9. So that's going to give me y equals negative. Well, 0 minus 4 is negative 4. And negative 4 squared is positive 16 plus 9. So I get y equals negative 16 plus 9, which gives me negative 7. Okay? So I have a y-intercept at 0, negative 7. Okay, 1, 2, 3, 4, 5, 6, 7. Here's a y-intercept at 0, negative 7. Okay, let's look at an x-intercept. Remember, with our x-intercept, we set y equal to 0. So this time I have 0 equals negative x minus 4 I squared plus 9. When I subtract that 9 over, I wind up with negative 9 equals negative x minus 4 squared. We need to divide both sides by negative 1 before we take the square root because we got to get rid of that negative. That's going to be 9 equals x minus 4 squared. I'm going to take the square root of both sides. So plus or minus the square root of 9 equals plus or minus the square root of x minus 4 squared. And that's going to leave me plus or minus 3 equals plus or minus x minus 4. Not plus or minus x minus 4, I'm sorry. We don't have to put it on that side. That means, once again, I am getting very similar x-intercepts as we did in question 4. So I have 3 equals x minus 4, or I have negative 3 equals x minus 4. That's going to be 7 equals x, or that's going to be 1 equals x. So I've got x equals 7. 1, 2, 3, 4, 5, 6, 7. And I have x equals 1. And I have a vertex at 4, 9. 1, 2, 3, 4, 5, 6, 7. 8, 9. I covered up part of my graph. 1, 2, 3, 4, 9. Okay. And then, of course, I have that axis of symmetry right there at x equals 4. Now, this time, it doesn't go up forever. It goes down forever. But it is still going out forever, okay? So remember, our domains are our x's, and I just said it's going out forever. As it goes down, it goes to the left and right. At the same time, it continues outward. So that's negative infinity to infinity. And then my range. Okay, it's bottom to top. Well, what's my lowest y value? I never get to it. It keeps going down forever. So that's a negative infinity. And what's my highest y value? That's going to be at 9, because that's where my vertex is at 4, 9. And that is actually equal, so we have a bracket there.